Good afternoon, class.
Good afternoon, sir.
How are you all? Good. I am also very fine. In our previous lesson, we discussed how to factorize two binomials. Let's review that lesson.
Just review.
Factorize the expression on the board. Are you finished? Good. What's the answer? Yes.
X into bracket X minus.
So x into bracket x minus y. Good. This factorization of a binomial. In today's lesson, we'll be looking at how to factorize a quadratic expression or equation. So in short, we are looking at quadratic factorization. What then is quadratic factorization? Let's write. It involves expressing a quadratic equation or expression as a product of two binomials. I repeat. Quadratic factorization involves expressing quadratic equation or expression as a product of two binomials. Is that understood? Yes. Good. Now let's look at the methods that we can use to do this factorization. One of the methods is by inspection. Another method is by using the quadratic formula. The third one is using completing of squares. Then the last one is graphical. In today's lesson, we'll focus our expansion on by inspection. So we are looking at quadratic factorization involving inspection. Now, every quadratic equation has this structure. So we are now looking at structure of quadratic equation. So ax squared plus bx plus c is a quadratic expression. When we put this expression to 0, then it becomes equation. Do you understand that? I want you to understand the difference between quadratic equation and expression. So without the equality, then it is what? An expression. But with the equality, it is equation. Now, before we factorize this using the method of inspection, this is what we do. First, the coefficient of x squared here, which is a quadratic term. It is because of this term. That's why we are referring to the whole structure here, quadratic expression. In absence of this term, bx plus c becomes linear. So this is linear. Do you understand that? Good. So the coefficient of our quadratic term, which is the a over here, we use it to multiply the constant, which is our c. So a by c gives us ac. Now, once this expression can be factorized using the method of inspection, then two conditions should exist. One, there must exist two numbers. When we multiply, we will get this result. Then when we add the same numbers, we will get the coefficient of x here, which is b. So assuming these two numbers are p and q, then we expect that p times q should give us our ac. Then the same p plus q should give us our b. Do you understand that? If these two conditions can be satisfied by the same p and q, then we say the equation or the expression is factorable by inspection. Do you understand that? Hence, the two numbers p and q will be substitute or replace b one after the other. So the structure becomes ax squared plus bx plus qx plus c, or ax squared plus qx plus bx plus c, meaning there is no order by which you replace your p and q with the b over here. There is no order. You can choose to replace the b by p followed by q, or q followed by p. Do you get a substitution? Yes. Are you sure? Yes. So once you do this, the next thing you do is the first two. What are they having in common? You factorize, like you did in our introduction. The last two, what are they also having in common? Then you factorize. That is all. Let's take one example and look at it. But before we target, don't write. Before we move on to the example, let's just touch on one or two basic importance of quadratic factorization in the real life. So you write real life application of quadratic factorization. In physics and engineering, the knowledge of quadratic factorization can be used to solve problems involving motion and energy. Use the knowledge of quadratic factorization to solve problems involving motion and energy. And in economics, the knowledge of quadratic factorization is also used to model economic structures and also make predictions. To model economic structures and also make predictions. Good. So you stop writing now. Let's move on to our first example. So x squared minus 4x minus 21. Don't write. Pens down, heads up. Stop whatever you are doing, focus on the board. What is the coefficient of the quadratic term? If you know it, raise up your hand, then you have the chance to answer the question. Yes, Juanita? Positive 1. Coefficient of x? Yes, Ivana? Negative 4. And then the constant term? You? Negative 21. So when we compare this to our general equation, our A is what? A will be what? All of you? 1. B will be? And C will be? Negative 21. So as I've established, you say our A will multiply C, meaning 1 will multiply negative 21, and that will give us. So we then look for two numbers. Of course, they are going to be factors of this. We expect that their product should give us negative 21, but their sum should give us negative 4. Do you understand that? So what two numbers can do that? If you know it, raise up your hand. Yes.
Negative 7 and 3.
Negative 7 and 3. Let's find out whether it is true. Negative 7 and 3. Negative 7 times 3. Negative 7 times 3 gives us negative 21. Negative 7 plus 3.
Negative 4.
Negative 7 plus 3. Negative 4. Is it true?
Yes.
So meaning our negative 4, which is our B, will be replaced by either negative 7 followed by 3 or 3 followed by negative 1. Negative 7. Are you okay with that?
Yes.
So we have x squared. Note the substitution now. X squared. We will not write the negative 4 again. X squared minus 7x plus 3x minus 21. So as I said, don't have to bring bracket. You only consider the first two. What are they having in common?
X.
So x out, x minus 7. The last two, what are they having in common? 3 out, x. How many times 3 going to 27? 7. Sorry, 21. That is negative 7. You get it?
Yes.
Then the next thing, if you know you are really doing the right thing, you can mark yourself. The factors that will be in the bracket must always be the same. Do you understand that? That is the key. So in examination, you can know whether what you are doing is right or not. So this will give us, so the outside one. So we are saying that this quadratic equation has these two factors. Meaning when we expand these factors, we'll get back to this equation. And since multiplication is commutative, you can write these factors as x minus 7, x plus 3. And you are both saying the same thing. Is that understood? Yes. Let us quickly expand one of them and see whether we'll get back to our quadratic expression. So let's do the expansion. We'll do the expansion here. X plus 3, x minus 7. That's binomial expansion. X times x.
X squared.
X times minus 7. 3 times x.
3x.
And then 3 times minus 7. Are they like terms?
Yes.
So can we add them?
Yes.
Negative 7 plus 3.
Negative 4x.
So x squared minus 4x minus 21. Is it giving us our quadratic expression?
Yes.
So we are saying that this quadratic expression can be factorized as this. And this is our objective for this section. So once an expression is given, and you can satisfy the condition that when we multiply the coefficient of the quadratic term by the constant, you can get two numbers whose product will give us that result. And the same two numbers, their sum will give us the equation of the linear term, which is negative 4 in this case, and we are done. To quickly write it, I give you one to try to see how best you have understood the explanation. Good. Let's make a headway. Try this. Let's see. 6t squared plus 5t plus 1. 6t squared plus 5t plus 1. Hurry up, hurry up. Hurry up. Present the work on the board. We are using T. We are using Q. We change the variable. You don't have to change the variable. Is that okay? Continue. That is it. So one is common here. So plus 1. 1 is common. Yeah. No, you are right. So just continue writing the root. Okay, cancel it. And write it. You can see what is in the bracket. Can't you see it's the same? That is all. So you are almost done. If you are finished, raise up your hand and I will attend to you. Okay. Let me see. You don't have to write a 6 here. It's still 1. You don't have to bring 6 here. It's still 1. Okay? Good. Okay, that's correct. Where are you? Yeah. So final answer. Okay, that's correct. You just want to find out whether it is true. That's fine. Good. Let me see. The factor. It's not 6. 6 times 1. Okay, give me 6. Two numbers, when you multiply, you get 6. When you add, you get 5. Look for them. Are you finished? Okay, stop whatever you are doing. Let's go to the presentation and see whether she was on point. Pens down. The presenter multiplied the quadratic term's coefficient, which is 6 here, by the constant term, 1. So 6 by 1 will give us 6. Then she identified, this is where your understanding should be focused on. 2 factors of this number, whose sum will give us the equation of the linear term. So 3 times 2. Have you seen that? 3 plus 2. So once these two numbers can satisfy the 2 conditions, then you can factorize by inspection here. Do you get it now? So quickly look at what she did. She replaced the 5 here by 2 followed by 3. And as I said in my explanation, I said somebody can use 3 followed by 2. You all get the same answer.
Yes.
Did somebody try that and get the same answer? Yes. Okay, so let's see. The first 2, what are they having in common? So 2t. The t's here are 2. So if 1 is out, you still be left with 1. And then 2 will go into 6 3 times. So minimum we use 2t to multiply 3t, we'll get back to our 6t squared. You get it? Those writings you stop writing. Then, yeah, the whole of 2t is out, so you'll be left with only 1. Then the next pair, what are they having in common? When I was moving around, I realized some of you are having challenge. You cannot identify what they were having in common. It's 1. So 1 out. You get it? So 1 will go here, the same thing. Now, as I said, once you are doing the right thing, what will be in the bracket will always be the same thing. That's the marking scheme. You get it? Then you put the outside ones in one bracket, followed by the inside one. And there is no order. Somebody could write this as 3t plus 1, followed by 2t plus 1. And they are all saying the same thing. Is that okay? Yes. Very good. Let me see about those who have this answer. Okay, clap for yourself. Good. So in short, we are looking at how to factorize a quadratic expression by method of inspection. Meaning there are others that you cannot use this approach. So when that happens, you can call on the formula, that's the quadratic formula, which generally students refer to as the almighty formula, or you can use the completing of square method. Any question? Any question? What have you learned within this period? What have you learned? Yes.
Quadratic factorization involves expressing a quadratic equation or expression which has 2 binomials. 2
binomials. Clap for her. So she's trying to remind us that to factorize quadratic equation or expression, we are trying to express it in what? As a product of 2 binomials. Do you understand that? Good. Any other thing? Yes.
I learned that in quadratic factorization, in the real life application in economics, economic fractures and other items can also be made.
Okay. So she's reminding us that we learned that the knowledge of quadratic factorization can be applied in economics to model economic structures or make predictions about the behavior of consumers. You understand that? Good. So we have come to the end of this session. You take this question as your homework. Right. 5w squared plus 5w plus 1. And then Remember to take your study seriously. Once again, thank you for coming.